In this video, we're going to take a look at one way a quadratic function can be transformed. First of all, let's remember that a quadratic function, standard form of a quadratic function, is f of x equals ax squared plus bx plus c. So that coefficient of the x squared term is the a that I'm referring to here. And if we change that, something very specific is going to happen to our graph. Namely, the graph will either get narrower or wider depending on that value of a. So we're going to look at the parent function, the parent quadratic function it's often referred to as, that just where we have f of x equals ax squared. And the parent function, of course, that would be equal to 1. So if this value a right here is, and we're going to look at the absolute value of it, because if it's negative, remember, it flips the graph down over the x-axis. So we're going to look at it in terms of the absolute value, and we'll talk about that a little bit more. But the absolute value of a is greater than 1. The graph is going to get narrower. Graph will get narrower. Okay? If the absolute value of a, again we do the absolute value because of those negatives flipping it, is less than 1, then the graph is going to get wider. Now, let's take a look at a few of these graphs, and I've set this up on the website to get to this graphing calculator is abettercalculator.com. It's a really neat graphing calculator that you can access online. It's abettercalculator.com, or if you go to this website right here, you'll get to it. So I encourage you to check it out. It's a wonderful graphing calculator. So I've set up right here, here's my parent function, x squared, and then I've set up two different functions where this first one, I have the values of a are going to be 1 to 20. So this is that first situation where we had x, the absolute value of a, being greater than 1. So what should happen there is my graph should get narrower. So let's check and see what happens. So right now it's at 1, so it's right on top of that parent function. As I make it larger, notice what's happening to that red graph. It's getting narrower and narrower. As we get larger, narrower and narrower. Okay? And so we go back here over to 1, and we're back to our original parent function. So larger than 1, it gets narrower. Okay, so what if it's less than 1? Well, here are the things that we could possibly have. It could go from 0 to 1, and notice what happens here. As we move this over, notice how the orange graph is spreading out. It's getting wider and wider. The smaller we get here, this would be 1/10. Notice how wide it is, all the way continuing down, continuing down. This would be 1/100th, until if we got to 0, actually it would be completely flat because it would be linear. The graph would just be linear because the 0 would get rid of our squared term there. So what we notice is that that graph is getting wider as we get closer to 0. So between 1 and 0, the graph gets wider. So let's take a look at a few examples here and see if we can't determine some things that are going on. So let's say that we're given this list and we're asked to determine we're asked to order the graphs from narrowest to widest. Okay, so thinking back about what we saw on the graphing calculator there, the narrowest one is going to be the one that has the highest value for the coefficient of the x term. So the largest and the largest absolute value. So as we look at these, the absolute value of this is going to be 1/2. The absolute value of this is going to be 3. and the absolute value of this one, this is just our parent function, is 1. So what we're going to do if we want to go from narrowest to widest is simply take those numbers from the largest to the smallest, and we'll get them in order from narrowest to widest. So my narrowest graph here is going to be the g of x, and I won't write the whole thing, but g of x, which is this. My next narrowest is going to be this one, the h of x. And finally, my widest graph in this case is going to be f of x. And remember, this is less than 1, so that's getting wider than that parent function. This is greater than 1, so that one is narrower than the parent function. So we're comparing both to the parent there. Okay, now this next one's a little bit more challenging because we've got all things that are less than 1. So what we know for sure is that all these graphs are going to open wider than that parent function that we had right here, the x squared. So, well, let's think about this one. We have 0.5 would just be 1/2, and let's look at it like this. So here's 0, here's 1. Okay, remember 1 opens up like this, and at 0 it's just flat. So as we move in this direction, it opens wider and wider and wider until it gets all the way flat. Well, let's order these numbers within this. So 1/2 would be right here. 1/4 would be over here. That's half of a half. And 1/3 would be between those two, somewhere about there. So 1/3 would be there. So if I want them from narrowest to widest, I just read here from the right. So the narrowest one is going to be f of x, the 1/2, with the a being 1/2, and the next narrowest is going to be the 1/3 one, which is h of x, and then finally the widest one is the 1/4, which is the g of x. Okay, so, and what you'll also notice is in this first one, I didn't really mention it, is that I didn't take into account, and the reason that we use the absolute value is that it doesn't matter whether the graph is opening up or down in terms of how wide it is. So the width of 3x squared is the same as negative 3x squared. And let me show you that really quick here. So let me just toss out these graphs, and I'm just going to throw that in here and check out how sweet this is as we graph this. Notice, okay, negative 3x squared and 3x squared. Okay, so I'm going to drag this up just a little bit. Let's see how neat this graphing calculator works. Notice that the width of the graph is exactly the same. The only difference is that the negative one opens down, the positive one opens up. Okay, so transforming a quadratic function by changing the a value, and remember that a is the coefficient of the x squared term. If that absolute value is larger than 1, the graph gets narrower. If the absolute value of that a is less than 1, the graph gets wider. And we can use that to be able to quickly tell which graphs, compare graphs, and tell which one might be wider than another one. Hope this video was helpful. One thing also to point you to, if you're interested in that specific graph that I showed you, I have set that up here and it's shared and available to you if you go to this website if you want to play around with it. And that graphing calculator again is abettercalculator.com. Do check that out. It's a wonderful tool for working on your math. Hope this video was helpful. Keep working hard on your math. You can do it.